Hi everyone, in this week's project, I'm going to be showing you how to repair a broken Ethernet switch. Let's get started. The first step in troubleshooting is to assess the issue. The issue with this Ethernet switch is that it's not turning on. As you can see right here, there are two lights. There's one power light and there's one managed mode light. If we go ahead and plug the device in, as has just been done, and confirm that it's in fact receiving power by using this non-contact voltage detector, you simply put this near the cable and press the button, and it clicks and blinks repeatedly to tell you that it's receiving power. It should turn on as soon as we plug it in. However, we're not receiving any power light. So this means the next step is to take it apart. Alright, the next step is to take the front cover off, set that aside, and then to pull the top cover off. It simply slides off, like so. Okay, as you can see here, inside the Ethernet switch, there are two circuit boards. One of them, this one here on the left, is the power supply board, and that power supply board connects to the main board right here with this connector. The main board has 4 controller chips on it, located right here, 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 and here. So, the golden rule of troubleshooting is thou shalt test voltages. The next step is to plug it in and check the voltages of this board right here on the left to make sure it's properly outputting the voltage required to the main board. I'm going to take my multimeter and measure the black and red output to see if it is indeed 5 volts. 64.9 volts AC are present on this heatsink right here. Don't touch it. If we measure in volts DC, the output of this power supply board, we can clearly see that there's absolutely nothing being output. Let's examine the components of the power supply board more carefully. Alright, the first thing we need to do is to take our meter, put it into continuity mode. If you notice here on the left-hand side of the board, right next to my thumb, this is marked F1. F1 means fuse, and if we go ahead and turn the board around, we can use the multimeter probes to test for continuity of the fuse. These 2 points right here, and we should get a beep. Yes, okay, so the fuse is good. The next thing we need to check are all of the capacitors. A lot of times the capacitors end up drying out, and they can actually even short together. Aha! There's your problem. You see this leg of the capacitor right here? Notice how crusty that is? It looks like the electrolyte spilled out. Let's go ahead and measure that with the ohm setting of the multimeter. It's kind of difficult to get the multimeter and the board in the same frame, but let's give it a shot. So if we go ahead and probe this point right here above the capacitor, this little ceramic capacitor, and right next to it we get, interesting, a reading of 0.4 ohms. That means the capacitor is nearly a dead short across the system. That's not really what we want, so we're going to begin by replacing the capacitor and see if that restores it to normal operation. You're going to need 2 things. You're going to need a soldering iron, and you're going to need a desoldering bulb. If you don't have a desoldering bulb, you can use a desoldering braid as well. Look at that. It's so crusty down there. Definitely in need of a replacement. Alright, I've found what I believe to be a suitable capacitor. It is 150 microfarads, slightly over spec, but it's 450 volts, and it should do the job just fine. Now we have some very nice connections to work with. Next I stripped back the wires, tinned them up, and now I just have to solder them in place. And just solder the wires to the circuit board, and trim them to length. Time to plug it in. Alright, with the meter set to DC volts, let's see if we get a 5-volt output. Wah, wah, wah. Nothing. Time to consult the schematic. Alright, so after reading online and consulting some technical manuals, it seems to me that the next most logical step would be to replace this little capacitor right here. It's a 25 volt, 47 microfarad capacitor, and apparently it controls something important, and a lot of people have had success repairing this power supply by replacing it. So I'm going to go ahead and give that a try. I'm going to be using this 47 microfarad 50 volt Nichicon capacitor to replace the one on the board. Alright, here goes repair effort test number 2. So I went ahead and replaced that little capacitor just like the way I did the first one, and now I'm going to plug it in. If everything's working right now, we should get 5 volts on the output. Here we go. Yay! We get a solid 5.072 volts DC. Perfect. We've successfully restored it back to working operation. We should get the light to turn on. There it is. As you can see, the power LED is illuminated, and the managed mode LED is lit. Alright, all that has to be done now is final assembly, and that is simply putting all the screws back in, finishing screwing in the power supply, and putting the lid back on. So now when you plug power into the back of the Ethernet switch, you can see all the lights light up at once for a brief second, and then the power light and managed mode lights come on. I just wanted to mention real quick that this Ethernet switch that I just repaired saved my school about $300. I go to a non-for-profit private school, and it really helps them out when I'm able to repair things for free. Thanks so much for watching, everyone, and I hope you enjoyed that. If you like these kinds of repair videos, leave a comment down below and give me your opinion. Also, please don't forget to subscribe and share this video. Thanks, everyone. Thank you all so much for watching. If you liked what you saw, feel free to click the subscribe button and check out some of my other videos.